Hey guys, here's a video to kind of remind you how the proof process worked. So what I'll do is I'll do a few examples, kind of like what we did in class the other day, to sort of refresh your memory in case you're having a little trouble. So here's one of the examples where they give you the lines are parallel, P and Q. No, it doesn't show it in the picture, so if you want, once you see that it's given, you're certainly welcome to actually draw that into the picture. Sometimes that helps. So you're given P is parallel to Q, and they want you to solve for X, okay? But the key thing here, I guess, is make sure to justify every step using the proof strategy we talked about in class. So by justifying every step, it means every time, excuse me, every time you write down a statement, you have a reason that matches it. So why did you write this down? Give a reason. Why did you write this down? Give a reason. And go from there. And just to remind you, on the front page, I'll bring that back up, we have our reason bank. Okay, so every reason you give should come from here. Okay, the only one that's not on this particular reason bank is given, is the given, but we kind of talked about how that was just sort of an automatic one. But if you have any, reasons that you think are the correct answer but just aren't in this box, well, then just ask. But for this particular practice packet, every single reason basically comes from here, or the reason is already given to you one way or the other. Okay, so let's go back to that example. We'll do it. And hopefully it, excuse me, hopefully it'll make sense. So we're given that P is parallel to Q. That's the first thing they say. So P is parallel to Q because it's given. All right, that's sort of like, where you start. The next thing you do is you try to find some kind of relationship between, any of the angles in the picture. Now, in this particular picture, there's only those two angles. But sometimes there's more, and you just want to start somewhere, and hopefully you have a reason for where you're starting. But in this case, you should recognize these two angles by their positions and realize that these are called alternate interior angles. So we know alternate interior angles by position, but we also know that they're congruent if the lines are parallel. So if they're congruent, I'll put the little marks for it. If they're congruent, well, then their measures must be the same. So 2x plus 43 must equal 5x minus 47. All right? These two angles are congruent, so their measures are equal. How do we know that those angles are congruent? Well, that's because of the alternate interior angles theorem. Okay, alternate interior angles theorem. And where did I get that from? Well, I happen to remember it, but in case you kind of forgot, all of the reasons are here, and you just got to find the one that matches. Now, I would hope that you wouldn't think that that's the addition property, right? So you want to try to find the theorem that matches what you wrote. So we use the alternate interior angles theorem. We did not use the converse. Again, let's look at the picture. We did not use the converse because the parallel lines were already given. If we were trying to prove the parallel lines, well, that's another story. Then we might use the converse. In fact, we probably will use the converse. But in this case, no. We just used the original theorem that we started with and kind of go from there. All right, once we have this part, well, now we just solve like we normally would, and you can kind of take your pick however you want to do it. I'll go ahead and subtract 2x from both sides. 43 equals 3x minus 47. Since I said subtract, I'm going to use the subtraction property. Now I'll add 47 to both sides, so that's 90 equals 3x. That's the addition property. And I guess I'll divide both sides by 3. So it looks like x equals 30 using the division property to finish it off. Property. All right, every single statement I made has a reason that matches it. I was given the parallel lines. I knew these angles were going to be congruent. Their measures were going to be equal because of the alternate interior angles theorem. Then I solved algebraically using all those properties that you've done in algebra before. Okay, and that's a full proof right there. All right, let's try another one. Let's see. Let's try this one. I'll just zoom in on that a little bit. Can I get it? There we go. All right, so the first thing they tell us is angle 1 is 115. So you know what? I'm going to actually put that in the picture. 115. Angle 3 is 65. I'll put that in the picture. And they want us to prove that lines L and M are parallel. All right, so I'm trying to prove the parallel lines this time. So I'm not given the parallel lines, so hopefully that rings a bell. But let's see how we get there. Because right now, there's no way we can say these lines are parallel. You can't just say, oh, they're both straight, you know, which I know some of us might think that's the reason they're parallel. That's not the reason they're parallel. We have an actual theorem or postulate that would justify it, but let's wait till we sort of put these pieces together first. So what are we given, right? They didn't tell us what was given in the boxes, but they told us what was given up here. So that's what's given. That's what I'm going to put. The measure of angle 1 is 115. The measure of angle 3 is 65 because it is given. All right, now let's look at the picture. These two angles here where the 3 is and the 1, there's no direct connection to those two. All right, now I know the numbers, you know, if you just do them, you know, if you just add them together, you can see that they would add up to 180, which is nice, but there's no justification as to why these lines would be parallel for those two. Oh, okay. Hey, Skittles. That's not really very helpful, so maybe we can just not stand on the table. Great. Thanks a lot. All right, so while these do add up to 180, that's not going to get us anywhere right off the bat. However, if I can somehow get these two angles to possibly add up to 180, that might do something for us. Hopefully you recognize these as consecutive interior. And one of our theorems is that if consecutive interior angles adds up to 180, then the lines would be parallel. So if there's some way I can get this 65 to match up here, we'd be in business. Well, hopefully you remember that these two are actually a special pair that we've learned. They're called vertical angles. So you've got your perfect crisscross, your perfect X. The angles across from each other are going to be congruent. So angle 3 is going to be congruent to angle 2. So the measure of angle 2 is going to be 65 degrees. And the reason would be, and by the way, again, look at your reason bank. There it is, vertical angles theorem. All right, so everything is there. You just have to remember how to apply it. So that would be the vertical angles theorem. Vertical angles theorem. And that gets us 2 is congruent to 1. And I'll put the 65 here. Now, at this point, I can sort of see an argument for somebody just saying, oh, now I know those two are supplementary, and then I can go right to my proof. But in this case, the proof's sort of set up for you, and they're basically telling you at this step, they want you to use the definition of supplementary angles to say something. So they're giving you the reason, you have to figure out what to say. So by the definition of supplementary angles, we must know that there are angles in this picture that add up to 180. Now, you could certainly say 1 and 3 are supplementary, but that's not going to get us to what we're trying to prove. But 1 and 2 being supplementary will get us to what we want to prove. So measure of angle 1 plus the measure of angle 2 equals 180, right? That's, and I'll just do it, I'll just write it down. So 115 plus 65 does equal 180, right? Just so you can really see it, because of the definition of supplementary angles. Okay? Or you can even say angle 1 and 2 are supplementary by the definition of supplementary angles. I would accept any of that, because to me that tells me you recognize that 1 and 2 are supplementary, which leads us to our next step, which is L is parallel to M, and L is parallel to M because you have consecutive interior angles that are supplementary, and that is the consecutive interior angles converse theorem. But Mr. Miller, we didn't use the converse on the last example. Why'd we use it now? Because as I've said many, many times, when you're given the lines are parallel, you can use the original, but when you're trying to prove the lines are parallel, you use the converse. Remember, every single one of these original theorems, right? The sort of the core four, right, of dealing with the transversals, these four right here, were used in the original to once the lines were already parallel. But as soon as we started talking about the converse, right, that was when the lines were trying to be proven parallel. So don't get confused because this is all in one line. Remember, there was a little bit of limited space in the box. So you have alternate interior angles theorem or the converse. You have alternate exterior angles theorem or the converse. In this case, we use the consecutive interior angles converse theorem. Okay, so we go back, just recap. We had to do a little bit of work to get the two angles that we wanted to match up. And then once we got those to match up, we recognize them as consecutive interior. And then you just got to recognize that we did use the converse this time. Okay, so if you're stuck on a reason, go to the reason bank and see which one makes sense, and hopefully you'll remember how that worked. All right, if you have any specific questions on any problems, let me know. The best thing to do, honestly, would be to tell me what you did. You know, like say, hey, in step 1 I did this, or step 2 I did this, and then I could probably help with sort of cleaning it up if there were any problems. Okay, I believe the answer key is already on Edmodo, so if you need me, just post your questions and I'll help you out. Okay, all right, I'll see you later. Bye.